اي بس 3 ساعات. ما كانش اليوم خفيف يعني ما 9 يعني
احنا ما نعرف كل الكورسات احنا والمادة السابقة
احنا في المنطقة اللي لجتك
شكل تعال والله اقول لك يوم السبت يا ابوي الشبكة مثلا في يوتيوب بس بلا بالك هذا جديد هذا جديد يا اصحاب انا اعتمد تو فيلكس قفل
Okay, gentlemen, I want you to turn off your mobiles. Settle down, turn off your mobiles, keep your mobiles in the pockets. Look at the screen for the full name. One student dropped, so the numbers have slightly changed. Ahmed.
Yes.
Bender. Ahmad Mustafa. Ahmad Ahmed. Hussein.
Yes.
Saud.
Yes.
Abdullah. Saud Abdulaziz. Salman Fahad. Ahmad Ahmed. Salman Abdullah. Faisal Fahad. Ahmad Abdullah. Fahad Khalid. Rahman Adil. Ahmad Suleiman. Ahmad Ahmed. Hamid. Ahmad Haytham. Adib.
Yes.
Ibrahim Hussein. Yusuf.
Yes.
Hussein Abdul.
Yes.
Hassan Ahmed.
Yes.
Abdul Hadi.
Yes.
Ahmed.
Yes.
Jawad. Ahmed. Abdulaziz.
Yes.
Ahmed Assam. Mishal. Saad Ahmed. Fahad Saeed. Abdulaziz Abdurrahman. Anyone who came during the attendance? Okay, today's class is more of an overview of what we have done, and we will try to connect it with what you have done in the previous course. So the derivational part is done now. We have already derived the distributions of beta naught hat and beta 1 hat. So we're just going to connect it with the hypothesis testing that you have done in the previous course, either 214 or 201 or 212. So based on the distribution of beta naught hat or beta 1 hat, I'll write everything for beta 1 hat. You can write the similar thing for beta naught hat. Let us say you're interested in hypothesis testing of the slope. Beta 1. So the question may ask you to test three possible hypotheses: the two-sided, the lower-sided, or the upper-sided. So your H naught H1 combination can be one of these three. Beta 1 equals to something against beta 1 not equals to something. It can be this, or it can be beta 1 greater than equal to something against beta 1 less than something, or it can be any number. For example, I say test that the slope is more than 7. So this number, constant number, is 7. These were the three cases you discussed. Now, for all of these cases, either you will be given a value of alpha or you will assume it equal to 5%. For all of these cases, you will be using a statistic which is based on T. And this T is what? It is beta 1 hat minus beta 1 naught divided by the standard error of beta 1, this one, MSE over and your degree of freedom is n minus 2. All the three cases. Now, once you are done with the calculation of test statistic, now you have the choice to either use the critical value approach or the p-value approach. So if you are using the critical value approach, your decision rule will be reject H naught if what? For first case, you will reject if the absolute value of t is greater than t alpha by 2 with v degrees of freedom. For the second one, you will reject if t naught is less than minus t alpha with v degrees of freedom. And for the third one, you will reject if t naught is greater than t alpha with v degrees of freedom. Where this value or this value or this value will come from where? From Excel now. Now it will come from Excel because you can generate the whole table in Excel. Then the second approach is what? Second approach is to use the p-value approach. And here you will reject H naught if p-value is less than alpha, where p-value is what? Where p-value in first case it is 2 times probability that t distribution with v degrees of freedom has a value greater than t naught absolute. In second case, it is probability of t with v degrees of freedom less than t naught. And in third one, it is probability of t v greater than t naught. Now I assume that you thoroughly know this table. In this table, I don't want you to memorize the things. I want you to connect everything with the sign of H1. Connect everything with the sign of H1. Look at H1 for case 1. What is H1? H1 is not equal to. Not equal to means either greater or less. And look at the critical region. It's either greater or less. Combined into a single statement of absolute. These are actually two statements. When you combine them into absolute, these are actually two statements, either greater or less. These are actually these two statements. Reject H naught if t naught is greater than t alpha by 2 with v, or t naught is less than minus t alpha by 2 with v. These two statements are equivalent to this one. Exactly equivalent. So connect it with H1, you will get the concept. Now look at the second one and connect it with the sign of H1. H1 is less than. The rejection region is less than. H1 is greater than. The rejection region is greater than. So the sign of H1, what is the rejection region? That is, you reject H naught. When do you reject H naught? When you go in the favor of H1. So when you're talking about favoring H1, when will you favor H1? The rule will be on the same side of H1. When you are going towards H1, in that case, you'll be favoring H1. Similarly, look at the expressions for p-value. P-value is, again, this one is because of the symmetry. It's the upper tail probability and the lower tail probability, both of them added together, which is 2 times. Why does it become 2 times? Because the symmetry of t distribution. T distribution is symmetric from left to right. It is symmetric. So you take the probability on one side and you take the probability from the second side. You add them, they will be equal. It's similar to multiplying the same thing by 2. For the case of less than, the probability is less than. For the case of greater than, the probability is greater than. Some of the common mistakes I see is some of the students, they mix up the two approaches. They write the p-value expression sometimes to be probability that TV is less than T alpha. They don't involve the calculated test statistic calculated in third step, T. They just take the critical value from the table, compare it with the distribution, and don't involve the data anywhere. This is one of the common mistakes I see.
Last step is what?
T naught is the value of this statistic. When you plug in the data,
TV is.
T is the T distribution with V degrees of freedom. You go in the T distribution and look for the probability of less than or greater than this value. Suppose I give you the data, and for that data, beta naught hat or beta 1 hat comes out to be 7. You plug in 7, and the corresponding value of T comes out to be 2.14. So what you will do is you will go in the T distribution with n minus 2 degrees of freedom, and you will look for the area less than 2.14. Again, this mistake, because it's not the expression of p-value. P-value is the probability in T distribution less than the calculated value of T, not T alpha, the calculated value of T, the value that comes from the data. Now we can write the similar expression for beta naught just by replacing. The only thing that will change is the formula of T. If there is T naught, then it will be the correct expression. And keep in mind, in exam or in real life, you will encounter one of these three situations, not all of them. You will either be interested in a two-sided hypothesis or a one-sided hypothesis. In one-sided, you'll be either interested in lower-sided or upper-sided. Now comes the next story, that from the question statement, how do you generate H0 and H1? Anyone who can specifically tell us, how do we generate H0 and H1? Let's say I write a question verbally. Test that slope is 0. What is H0? What is H1? Beta 1 against. What if I say test that slope is not 0? Same? Why same?
H0 is always with the equal sign and not equal with H1.
Okay, what if I say test that slope is less than 0?
Equal in H0 and less than in H1.
What will be H0?
So because we said beta 1 less than 0, because the statement that said less than 0, so it goes with the alternative.
Let me keep going. I'll tell you the rule. Let me keep going. Yes. What is H0, H1 for this example? Same?
Yes.
What is the rule you are following?
Equal. The equal sign should be in the H0.
Why don't I make H0, H1 like this? For this question. I also didn't understand what he's saying. Just trying to.
It should match the statement and the equal sign should be in the null hypothesis.
Yes.
The alternative hypothesis should not contain any equal signs.
Yes.
So
What's the rule?
again, I don't know.
What's the rule?
Satisfy the equality that describes the statement, and then if it has equality, put it with the H naught. If it doesn't, put it with the.
I can tell you majority of the students, for at least they will make this hypothesis. Although it is wrong. Although it is wrong. This is wrong. Why it is wrong? Because the statement is nowhere. Where is the statement in your hypothesis? Is it in H1? Is it in H0? No, it's not. Or the wrong, it's not, it's nowhere. Where is at least 0? It's nowhere. So here are the 3 simple steps of making H0 and H1. Step number 1, write down the statement in notational form. For, let us say, this question, what is the statement in notational form? Beta 1 less than 0. Don't call it H0, don't call it H1. Just write down the statement in notational form. That's step number 1. Write down the complement of the statement to cover the whole sample space. A union A complement is sample space, right? We need to cover the whole sample space. Write down the complement of the statement. What is the complement of this statement? Let me choose to write it above. Whatever is the statement, whether it contains equal sign, it doesn't contain equal sign, don't bother about it. Just write down the statement, number 1. Write down the complement of the statement, number 2. You will have 2 statements, 2 hypotheses. True. One will contain equal sign, one will contain no equal sign. The one with equal sign is H0, and the one with no equal sign is H1. This is it. And here, for your convenience, this will help you at the last step. For your convenience, write in bracket which one is your statement. This is your statement. This is your statement. So at the end of the procedure, if you choose to reject H0, you are favoring your statement. So you will interpret it like this, that the statement is true. And at the end, if you fail to reject H0, you will say that we don't have enough evidence to say that the statement is true. We go with the opposite statement. So this makes the life easier for the last step. Now, what is your question? Equal sign always stays with H0, always stays with. For any hypothesis, whether you are testing beta or you're testing mu. The reason for this one is we derive the distribution of test statistic under H0. So what's the best thing to do? Forget about why it is with H0. Just remember it is with H0. Okay? All the theory you developed, what is the distribution of beta 1 hat? Normal? Normal. This is what you developed in previous class here. Where is it? Here. Where did I write it? Where did we develop the distribution of beta 1 hat? Here. We developed it under H0, assuming that beta 1 is beta 1. We develop it under H0, and then we try to see that does the data match with this development or not. If the data matches this development, you accept H0. If the data doesn't match with the theory you developed, you reject H0. Now, let me write the third one. This is a very crucial step because the remaining steps, the critical region, the p-value, the conclusion, everything depends upon this. If you make H0, H1 wrong, obviously your rejection region will be wrong, your p-value will be wrong, your conclusion will be wrong. Let us solve an example. Let us go back to the data that we are dealing with since last week. The data is about this a part of the rocket. It's a propellant part, and the variable of interest is the strength of this part. And it is told to us that the strength is related to the age of the part. If it is an old part, it will lose strength. And same is confirmed through the scatter plot that we drew. If you look at the scatter plot, you will see the linear negative trend, which means as you go along x-axis to the right, y is coming down, which means if age is increasing, the strength is decreasing. Now here is a question. If this is the scatter plot, what is the type of relationship, positive or negative? Negative. Beta 1 will be. Are you confident enough that beta 1 will be negative for this one? Yes. We are very confident. Very, very confident. What about this? Negative, probably, but less confident. Seems negative, but very, very less confident. Let's say it is linear and you draw a line like this. It seems negative, but I can also draw something like this from this. So I'll be less confident. So where am I moving towards? In between, there will be a point. If I go upwards, there will be a point where I'll be confident on my statement that the relationship is really negative. When I move from downwards to upwards, you see the pattern? The points are getting close to the line. There will come a point where I will be confident in my state. Am I confident here? Here? No, I'm not confident here. I'm not confident in my statement that beta 1 is negative. It seems negative, but I'm not confident in my statement. Here, yes, I am confident. So that means in between these two diagrams, there was a point above which I started becoming confident that the relationship is really negative. Now, this will be the interest in most of the examples. You need to see whether the relationship is really negative and really significant or not. So let us say we are testing in this question, test that the slope of line is negative. I can ask the same question in another way. Test that the relationship is negative linear. I can also ask the same question, test that due to an increase in age, strength decreases. All of them are same things. First, I'm asking very straightforward, beta 1 is negative. Second, I'm asking in terms of correlation, that the relationship is negative. Third, I'm asking in terms of the interpretation of beta 1. Beta 1 is the change in y due to change in x. So I'm asking in terms of interpretation. but all three of them, I'm asking you to test that beta 1 is negative. This is the statement. All three of them. What is the opposite of this statement? Which one contains equal sign? Let's say alpha is not given. What will you assume? You will assume it could be 0.05. T statistic will be beta 1 hat minus what is beta 1 not? 0, the value of beta 1 that you're testing in H0, right side of H0 or right side of H1. 0 whole divided by MSE over SXX. Now let us go to the Excel file and find this T. The final answer of this T will be called T0. And that is what we will compare with the critical value to get to the final decision. Yes. Any questions? Now I'm going to go to the Excel and I will find this T. And we have worked out a little bit in the Excel file up to what point? Up to the point where we have SXX, SYY, B0 and B1. We have already worked up to this point. So if you look at the formula, there is beta 1 hat in the formula. We have that beta 1 hat to be minus 37.15. Can you all see it? We need SXX. There is SXX here in the formula, which is 1106.559. We have it. The only thing that we need to calculate is what? MSE. So let me go back and see what is MSE. MSE is SSE over n minus 2. Here it is. Is it visible? The font size is big enough. It is SSE over n minus 2, where SSE is the sum of squares of errors, which means I need what? I need a column of errors. I think I have it. Do I have it? Yes, I have the column of errors. So the only thing I will do is I will square this column and take the sum of squares. That will be SSE. Dividing it by n minus 2 will give me MSE. So let me find EI square in this column. I write equals H2 whole square, and then I drag it down. And this formula is taking the sum of columns. I drag it rightwards. It will take the sum of the last column also. So your SSE comes out to be 11 something point this. So let me write it here in my file that my SSE is this. And finally, my MSE is this thing divided by 18. If someone is interested in writing the formula in Excel, you can write it like this. Let me tell you. Suppose here you enter the value n, which is 18, right? So in 18, how do we, how do I review formula? Yeah, define name. Go to the formula, define name, and this thing will be called n. Right? Now in MSE here, instead of clicking on the cell, I can write simply n minus 2. Because I already defined n to be column that column which is B, n is 20. So I can just change it to 20. Everything will change. Now I already told Excel that B24 denoted by n by going to the formula and define name. This cell is called n now. From now onwards, I don't have to click on B24. I don't have to write B24 every time. I'll just go to the formula where I want to write and write n. N will automatically be considered as B24. Yes. You go to the defined name and remove it. Where is it? You go to the defined names. Is it? How do I remove it? Name manager on the left side of name. Go to the name manager and you will see all the names assigned here. So click on the one you want to remove and delete it. For defining anything, for example, I want to define this number as SXY, right? I'll click on this one, go to the formula, click on define name. Because I have already clicked onto the cell B25 and on the left side of B25, the name is already SXY. Excel already picked it by default. But if you want to give a different name, you can enter a different name here. And I click OK. Now this cell is saved as SXY. I don't need to click every time. Yes. Yeah, valid. We had the wrong MSE. We need to put bracket. Over n-2 is in bracket. Thank you. Any question up to this point? Bonus. Any question up to this point? Clear? Now let us calculate the t value against this B1. So this will be T0 against this B1. This will be B1 beta 1 hat. And for your reference, I'm going to write -0 here so that you know what is beta 1 naught. The value of beta 1 that you are testing in H0 over square root of what? MSE over SXX. It comes out to be -12.859. Now, a shortcut. The moment you see that the value of t, if you are testing a two-sided hypothesis or a less than, if you're testing less than, the moment you see a value of t is very big in negative, it's supporting the rejection away from 0. It is supporting the rejection. Now from here onwards, I can either go for the critical value approach or I can go for p-value approach. Let us say I choose the critical value approach. Yes. You are raising hand. No. For the critical value approach, what do I need? My hypothesis of which type? Less than or greater than? H1 is less than. So I'm in which case? I'm in the middle case. I'm in the middle case. So my rejection region will be, I need a value from T distribution where the lower tail area is alpha. Lower tail area is alpha. So when I multiply it by minus, the upper tail area is alpha. And when I multiply it by minus, I'll come to the left side. With degrees of freedom, what happened? Strong. Can you see it? Before I move on, let me draw the curves for you for these critical values so that you know it from where to get the point. No, recording, I think, is going. To get the critical value, basically, suppose this is your T distribution. Suppose this is your T distribution with, let's say, V degrees of freedom. This is plus infinity, this is minus infinity, and the center of T is like Z, the center of T is 0. Now, where is the critical value? The critical value is somewhere here. And we call this one to be TAV, where the upper tail area is, this is A, such that the upper tail area is A. That's why this constant is called TA with V degrees of freedom. Why there is a in the subscript? Because the interpretation is that the area above this value is A. Why there is a V in the subscript? Because we are going to the T distribution with this specific degrees of freedom. The limitation of Excel is what? The limitation of Excel is that by default, Excel will take the lower tail area and not the upper tail area. Like Minitab also, gives you the lower tail area. And if you have to calculate the upper tail area, what do? 1 minus. So Excel also gives you the lower tail area and not the upper tail area. So if you are interested in this point, the value you will plug into the Excel is 1 minus alpha and not alpha. No, you can't. So in Excel, to get T alpha, you plug 1 minus alpha in there. So let us go to Excel now, and I will show you what happens. Let us go to alpha Excel and first plug in the value of alpha. What is alpha? Let's say 0.05. What is T alpha with, let's say T alpha equals. Now here is the question. Do you want the value or do you want the probability? Critical region approach. Go back to this diagram. Are you interested in the value or you are interested in the probability? The value. If you are interested in the value, the command is T dot inverse. And if you're interested in the probability, the command is T dot distribution. So I write T dot, you see the options, there is distribution and there is inverse. So click on T dot inverse. And what do we need here? We need to put the probability here. So I'll not put directly alpha. I'll put what? 1 minus alpha. And then the second argument, it is asking for what? Degree of freedom. So that will be n minus 2. When I put it in, I'll get the constant, which is 1.734. If you go to the T table, it will give you the same constant. Maybe round it up to 2 or 3 decimal points, but it will give you the same constant. Now here you have the option to take any degree of freedom, any alpha. Unlike the table where you can only take some degrees of freedom and some values of alpha, they are available. Here you can find the critical value for any degree of freedom and any value of alpha. So this is T alpha. This is T naught. What is the decision rule? Come again? No, the value itself is positive and then there is a negative in the formula. You are right. Conceptually, you are perfectly right. Look at the middle formula. You see, it should be negative. The critical region should be on the negative side. So ultimately, when you multiply it with negative, it will become negative. Because you are testing less than H1, so conceptually, the critical region should be negative, and it is negative. Yes.
Could you please further explain the T cases for the T distribution for all 3 cases?
The distribution for all 3 cases?
No, I mean the critical value. Sorry, when we are interested in the upper tail and the lower tail.
Before that, let me repeat the point, how to get the T critical value and how to get the from the expression P equals probability that in TV is greater than, sorry, less than T naught. From this expression, P equals probability that TV is less than T naught if we want P. The command will be T dot dist. We are interested in the distributional probability. The command will be directly t dot list. But if you are interested in t naught, you are given p, but you're interested in t naught, you have to use the inverse use of the table. You remember? The reverse use of z table, inverse use of the z table. You look for the value inside the table and the corresponding value is z. You remember the use of the table? In the course, we used to call it inverse use of the table. So if you want t naught, the Excel command will be t dot inverse, where you will use the inverse of the distribution. This will give you this. You will need this command for finding the p-value. And you will need this command for finding the critical value. When I use the p-value approach, I will use the first one. When I'm using the critical value approach, I'll use the second one. Now, what was the question?
Question was about values. When we are interested in the upper cell or the lower cell.
When the question says, here in this question, your H1 is lower tail, critical region will be lower tail.
Okay, and how we found the lower cell with the critical value? How did you associate the critical value with the H1? Because I see the sign is always the same.
No, the sign is negative here.
No, I mean the you call that just one equality sign.
Where?
When it's negative, B1 is less than B naught.
Mhm.
We have less than, we have greater than, we have greater than. So how did you associate that with the sign? Equality sign.
The equality sign, no, H naught doesn't matter. When you're talking about the rejection region, H naught doesn't matter.
Okay, so we
H1 matters.
H1. Okay. So how are they associated? Why is when this is
When that is less than, this is less than.
yes.
When that is greater than, this is greater than. How they are associated, look at the statement. What are you writing? You reject H naught. When do you reject H naught? When you are favoring what?
H1.
H1. So you will favor H1 when you are towards H1. And what is the direction of H1? H1, if it is less than direction, you will be favoring if T is also on the direction of H1.
But if it's alpha over 2 and this is alpha in the other two cases, what's the reason?
Think about it.
Yeah, just in the lower tip. Why did we put 1 minus alpha?
It's not something theoretical. It's the notation. The books put it alpha. The books give the notation from the upper side. You can give your own notation from the lower side. You can call it T1 minus alpha. And you say my notation is that I'll put the subscript, whatever is the lower tail area, I'll put it in the subscript.
Then
By default, it takes the lower tail area. Yes. We want the lower tail. No, sometimes we want the upper tail. Most of the times. Yeah. Yes, I wrote 1 minus alpha.
Yeah, but he asked you that you want the lower test. So why?
Yeah, in Excel, what I'm trying is I'm trying to catch the ear from this side. I can simply write, yes, he's right. I can simply write alpha, it will give me negative 1.74 something. That's only true for T distribution because T distribution is symmetric. That will only happen for T distribution. If I directly put alpha there, I will get directly minus 1.75 something. This minus sign will be taken care of directly. But this will happen only for T and Z distributions. This will not happen for chi-square distribution. Chi-square is not symmetric. T is symmetric around 0. Whether you take a point from the left side or multiply it by negative sign, or you take directly from the right side, these are same things. These are same things. Yeah, you can find, yes, what he's saying is you can find the critical value directly with putting alpha into the Excel. In that case, you don't need to multiply it by minus. Just put alpha here and you will get minus the same thing. Why are you getting the same thing? Because T is a symmetric distribution. Whatever is on the left side, mirror image is on the right side. So whatever was there, negative is in the negative on the left side. But this will not happen for most of the distributions. Last comment. I'll complete this example in the next class, but the last comment. Case number 1 for you. Last comment is about not equal to. When you are testing beta 1 is not equal to 0, beta 1 not equal to beta 1 not, you expect your T to be around 0. Because you see in the numerator, you are subtracting that value. So you expect your T to be around 0. When T is away from 0, either in the positive direction or in the negative direction, that's an evidence that beta 1 is not equal to the specific value you are testing. So either if T is here or it is here, far away from 0 on the left side or far away from 0 on the right side, you will be rejecting. So your rejection region is on two sides of H0. It's here and it's here. And because you have a restriction that the overall size of the rejection region should be alpha, what you do is you simply divide it by, you put alpha by 2 here and you put alpha by 2 here. Now this value is called T alpha by 2 and this value is called T1 minus alpha by 2 in most of the literature. But what your books denote it by is they call this value by T alpha by 2 and this one by minus T alpha by 2. That's what your book is using. Most of the books are using the other way. The theoretical books are using the other notation. They denote by the lower tail area, but your books are denoting it by the upper tail area. You can write. Writing is not a problem. It's the problem of conceptual thing. What you understand, that's more important. Then, due to the symmetry of T distribution, this value and this value are same. It's just the difference of the sign. So the actual critical region is this: reject H0 if T naught is greater than this value, or reject H0 if T naught is less than this value. You merge these two statements and they become reject H0 if T naught is greater than, the absolute is greater than T alpha by 2. But basically the rejection region is two-sided. It is coming from the two-sided. This is the summarized statement, the last one you see here. This is the summarized statement. Right? Now for the second case, your H0 is that it's greater than or equal to, H1 is that it is less than. So here is the distribution of beta 1 hat. Again, if it is equal to or greater than, you expect the T to be equal to 0 or greater than 0. But if T is in the negative, that is supporting your H0. Sorry, that is supporting your H1. How far negative? Let's say this far. How do you define this one? Based on alpha. Now, because your size of critical region is all on one side, you don't divide it on two. Now, this value, basically, you can directly get it from Excel by putting the less than area alpha. This value will come out to be minus 1.734 something. You can directly get it from Excel by putting alpha. But what your books and your tables have been doing in past, they are giving only the positive part of the T distribution. They don't give the negative part. And what they say, they ask you to take the same value from the positive, 1.734, and multiply it by a negative sign to get to this value. Most of the books in the most of the tables, they give only the positive side of the T distribution. You will not see negative values there. How do they handle the negative? They say that just take the positive and multiply it by the negative sign. You'll go to the other side of the distribution. And same is true for the third case. The third case is you will reject if T naught is greater than this value. Here is your rejection region. And all of it is alpha. Now, in the next class, we will keep continuing discussing the same example, and we will complete the critical value and the p-value approach for this example. If you have any questions, you can stay, otherwise you can go. Number?
يعني
30? Mishal Suleiman? 32.
Yes.
27 Jawad.
تدري فينا شو يسوي؟ يقول اللي خلص اول واحد ياخذ 10 الثاني ياخذ 9 بوينت شيء حتى لو خليك صح حتى لو خليك ثاني واحد شويه